Hello class. Today we're going to go over 4.1 right triangle trigonometry and applications. So the first thing I want to do is draw a triangle for you guys so that we can use some trigonometry. So the first thing we need to do is draw a right triangle, and I'm going to call this angle here theta. And I'm just going to label it so you guys know. So this is adjacent. This is opposite to the angle theta. And this is the hypotenuse, just so you have the names to them. And then we're going to also label them. So I'm going to label this one A, this one B, and this one C. So then when we use these rules that are down here, sine will be the opposite over the hypotenuse, or B over C. Cosine theta will be adjacent over hypotenuse, tangent adjacent over opposite, and then cosecant is just the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. One thing that you may have seen in the past is SOHCAHTOA. This becomes extremely useful if you can remember this acronym. So it's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Alright, so let's see if we can come up with an example for you, and see if we can figure out from one triangle if we can figure out everything. So if I gave you a triangle that look like this, and it's a right triangle, and I said this was theta, and this is 3, and this is 5, could we find this side? Well, obviously the answer is yes. We know that 3 squared plus b squared is going to be equal to the hypotenuse squared, so 9 plus b squared is equal to 25, so b squared is equal to 16, and b is equal to plus or minus 4, but since we're talking about a distance, it has to be 4. So then we'll go ahead and label that as 4. We found that. Now that we have those, let's see if we can, from theta, find all of our trigonometric functions. So then sine of theta is going to be the opposite over the hypotenuse, so that's going to be 4 over 5. Cosine of theta then was going to be the adjacent over 5, which is the hypotenuse. Tangent of theta will be the opposite, 4 over the 3. And then, like I said, the others are just reciprocals. So then cosecant theta is going to be the reciprocal of sine. Secant of theta will be 5 over 3, and then cotangent of theta is going to be 3 over 4. And that's all 6 trigonometric functions found for that angle. And I guess I called it angle x. I should have noticed that. So really, which this should be here should be angle x. And then all of these thetas should actually be angle x. So that should be an x, that should be an x. My apologies, I should have read the question. Okay, the next thing to look at is the complementary angle theorem. And it says that cofunctions of complementary angles are equal. And so let me just draw a picture of this so you guys can see. So again, we're dealing with these right triangles, and if I call this capital B and this capital A, the opposites to those angles are the lowercase sides. So then this guy would be capital C. So what this is saying is that if sine of angle B, we know is B over C, we also know that cosine of angle A, so cosine of angle A, this is, if this is A, the opposite of A is going to be, the adjacent of A will be B, and the hypotenuse is C. And so what we can see is that cosine of A is equal to sine of B. So the cofunctions of complementary angles are equal. This is all it's saying, is if I go sine of B, cosine of A should be equal. If I go cosine of B would be A over C, and sine of A would also be A over C. If I did tangent of B, that would be B over A, and then cotangent of A would be B over A. So these are just some examples of what this theorem is saying. So we end up finding that that's equal to that, and that's equal to that. So there you go. Now let's use it as an example and see if we can figure out some things here too that could be useful. And so sine of 60 degrees, that should be equal to cosine of 90 minus that 62 degrees. And the reason that is because if I had a right triangle, right, and I said that this was 62 degrees, this guy over here would have to be the difference, right? It would have to be 28 degrees in order for this to be a right triangle, right? Because we know that angle A plus angle B plus, and actually I should use capitals if I'm going to be doing this correctly. So let's say angle A, angle B, and angle C, they should add up to 180 degrees. And so if I have sine of 62 degrees, cosine on the other side would have to be, since it's a right triangle, 90 minus the 62, right? And in all of these examples that we're talking about right triangles. So in this case, tangent of pi over 2, then that would be cotangent, and then 90 degrees in radians is the same as pi over 2, and that minus the pi over 12 would give us cotangent of 5 pi over 12, and that is equal to tangent of pi over 12. Again, just this complementary angles theorem. Okay, I've already given you a bit of information that you're about to see, so that we know that by Pythagorean a squared plus b squared is equal to c squared, and that we know that the other two angles of a right triangle have to add up to 90 degrees. So I know that in this example, 62 plus 28 degrees has to equal 90 degrees. Okay, so let's do an example. And again, we're talking about right triangle, so let's make a right triangle. And so if I say this is, if angle A, let's call this angle A, if that's 40 degrees, then this has to be 50 degrees because 40 plus 50 adds up to the 90. 40 degrees is my A, so this is side A. B is this guy, and C is this guy. So we can see we've already found capital B, and the way that we found that was by going 40 plus B was equal to 90. Now it's asking us to find AC, right? Because we're provided with B. So our B, in fact, I'll just keep it there, B is 2. And so how can we find that? How about we use some of our rules? So how about cosine of 40 degrees? And cosine of 40 degrees is going to be the adjacent, so 2 over the hypotenuse C. And so when we go to solve this, isn't C going to be 2 over cosine of 40 degrees? We're going to need a calculator to do this. And so when you're doing this, since this is in degrees, you should be in degrees. and you should get 2.61 as that distance approximately. So when you guys are doing this, remember you're in degrees for these because we're talking about degrees. If I had it in radians, then you would do it in terms of radians. Okay, to find my A, because now we have C, it doesn't matter which angle I'm going to use, but I'm going to use 40 again. So if I'm using 40, I want to go opposite, and I want to go with what I know, what was given, and so I want to go opposite with adjacent. And opposite with adjacent then is going to be tangent of 40 degrees. And tangent of 40 degrees is the opposite, like I said, over 2. And so 2 times tangent of 40 degrees is my A, and so A should be approximately 1.68 as a length. So we saw that we found A, C, and B, which was the things that we were looking for in this problem. Again, SOHCAHTOA is so very helpful. You really should remember that. It's going to be important. Now, one other thing that I wanted to show you that's important is some notation, some terminology, and that's angle of elevation and angle of depression. So here, when we're looking at angle of elevation, you can see we're moving in a counterclockwise fashion. That counterclockwise fashion moving up is an angle of elevation because we're going from horizontal up, and angle of depression is going from horizontal down. So that's the angle of depression. Okay, now that's going to be useful for your homework. I want to do a quick problem for you guys, and this is the problem here. So we have a building, the Board of Trade building in Chicago, and it's got a statue on it. So I'm going to draw this building and I'm going to put a statue on it. All right, so I'm not the greatest artist, but there's a statue, and it tells us that from the center of the building to some distance away, and that distance is 400 feet, right? We have 2 angles. It tells us that we're going to have an angle to the base of the statue, so I'll do that in black. And we know that that angle right there is going to be 55.1 degrees. And then in a different color, let's say I do it in red, to the top, to that same point, I should draw that a little bit better. That angle there is going to be 56.5 degrees. Okay, now, and the problem wants to know how tall the statue is on the top of this building. So really what we end up having here is we have 2 triangles, right? So we have the triangle to the feet of the statue, and so that's going to be drawn this way. It's a right angle, and we know that this is 400 feet, and we know that this is 55.1 degrees, and we obviously want to find this B height. So we have an angle, we have an opposite, and we have an adjacent. So based off of that, opposite and adjacent, we should use tangent. So then tangent of 55.1 degrees is equal to the opposite over the adjacent. And so B is going to be 400 times tangent of 55.1 degrees. And that's going to yield 573.39. And that's approximately, right? That's approximately. Now, the other triangle that we're going to have, ooh, that's not flat. I want to draw it flat. So the other triangle we're going to have is to the top of the statue's head, and we know that that's going to be 56.5 degrees, again with that 400 feet of distance, and we're going to look for a B prime. We'll call it B prime in this case. So again, this is tangent. So then tangent of 56.5 degrees is going to be equal to this B prime over 400. So then B prime is going to be 400 times tangent of 56.5 degrees. And that's going to yield a B prime of 604.33. And this is feet, and this is feet also. So then the height of the statue is going to be their difference, right? So then the height of the statue is 604.33 feet minus 573.39 feet, which is going to give us 30.94 feet. Or we can say that's about 31 feet tall. Okay. If I did this kind of quick, please go ahead and stop the video and rewind so you can rewatch this. But the trick to it is I ended up with two triangles, right? The black triangle and then the red triangle. And again, I ended up with the right angle for this problem because here is the right angle that's going to take us up from there, right? This should be very useful. If you have any questions, please go ahead and ask. As always, all the best.